This meeting is being recorded.
For problem 10 from chapter 22, we are given our product that we are trying to synthesize here, these following amines, A through C, and we're told to either start with a corresponding alkyl halide for that amine or a carboxylic acid. So what I've done here below is we'll start with, say, compound A here, butylamine, and then we would consider two different pathways here. So in black, I have, if we had the alkyl halide, bromopropane, we could follow that. Those 2 steps in that mechanism, or 3 steps technically total, with the water workup at the end. Or we could follow the path in orange. So let's take a look at part A here. If we were to begin with this 1 bromopropane shown and use sodium cyanide here as a reagent, we could perform this substitution reaction and end up with this intermediate product shown here that has that nitrile functional group there, that CN triple bond. At that point, we can use the reducing agent, lithium aluminum hydride, followed by water in a workup step, and we can produce our target amine shown here. Now, if we want to follow the orange pathway, we could begin with the carboxylic acid, butanoic acid. So that's shown right here in orange. Then again, following the orange path, we'll add thionyl-chloride, SOCl2. That gives us this acid chloride here. See, we still have the same number of carbons. We've just swapped out that hydroxyl group for that chlorine. Then we treat this acid chloride with some excess ammonia. That becomes this amide shown up top here. And then once again, we do the same reduction step at the end with lithium aluminum hydride and water, and we end up with our butylamine that we're looking for. All right, let's take a look at compound B now. So we have our 2 pathways once again. So if we began with benzyl bromide, shown down here in black, we did a substitution using sodium cyanide. We could end up with this intermediate here. After that substitution, then we do a reduction and we end up with our target product here, that amine at the end. Or we could start with this phenylacetic acid shown in orange up top here. Then we do our treatment with thionyl-chloride, SOCl2. That gives us the corresponding acid chloride for that carboxylic acid. Then we treat once again with excess ammonia. We end up with an amide intermediate product. And then once again, the reduction as our last step, lithium aluminum hydride followed by water workup to give us that same product amine for part B. Hopefully you see a pattern, depending on if you start with an alkyl halide or carboxylic acid, you follow very similar steps, just with slightly different starting materials. So now we'll look at the last part C here. We have the black path below. We'll use bromo, cyclohexane shown there at the end on the left. Treat that with sodium cyanide. We get the corresponding cyclohexane with the cyano group here. Now we have to reduce that using lithium aluminum hydride and water to get our final product here. Then if we chose the cyclohexane carboxylic acid pathway in orange up top, we're going to follow the same steps that we saw previously in parts A and B. Thionyl-chloride in step 1 here, then treatment with excess ammonia of the acid chloride to give us the amide. Then last, we'll treat with lithium aluminum hydride and get that same target amine product.